So in this video we're going to look at using the quadratic formula when there are complex solutions. So here we're given a quadratic equation, negative 4t squared equal to negative 6t plus 5. And what we want to notice first is that it's not equal to 0. And if it's not equal to 0, we can't get our values for a, b, and c to put into the quadratic formula. So step 1 is get your quadratic equation equal to 0. So I'll rewrite my negative 4t squared, and then I'm going to add 6t to both sides, which will give me plus 6t on the left-hand side. And then I'm going to subtract 5 from both sides, and then once my quadratic equation is equal to 0, I can get my values for a, which is negative 4, my value for b, which is the coefficient on the linear term, is going to be positive 6 because of the plus sign, and c is going to equal negative 5. I have to take into account the minus sign in front of the 5, so this is going to be a negative 5. So here's my values for a, b, and c. The next thing I want to notice is that my variable is t, not x. So in the quadratic formula, I'm going to put t equals instead of x equals. And because it's a formula, I need to put t equals, or I get marked down when I'm in exam settings. So it's going to be t equals, and then it's the opposite of b. So the opposite of 6 is negative 6. Then we get our plus or minus the square root, and it's going to be b squared, which is 6 squared, minus 4 times a times c, and a is equal to negative 4, and c is equal to negative 5. And pull my radical all the way over everything that's supposed to be underneath it. Fraction bar O underneath the entire numerator. And then I get 2 times a, where a is negative 4. And once we've loaded the formula, we just begin to simplify it. So we have negative 6 plus or minus the square root. 6 squared is going to give us a 36. I get a negative times a negative is a positive. A positive times a negative is a negative. So this is going to be minus. And I'm going to have 5 times 4 is 20. 20 times 4 is 80, and then pull my radical over both numbers. Fraction bar under the entire numerator. 2 times negative 4 is negative 8, and just continue to simplify. Negative 6 plus or minus 30, I have the square root, and it's going to be 36 minus 80, which is negative 44, all over the negative 8. And at this point, I can see that I have a square root of a negative, so this is going to be a complex number, or 2, because of the plus or minus 2 complex numbers for my solution. So I probably at this point should break it into the 2 fractions. So the negative 6 will be over the denominator of negative 8, and then the plus or minus, and then I'll get my square root. And then I want to, my square root, I'm going to have square root of some stuff, and it's going to be all over the negative 8. And I probably want to start simplifying this. So the square root of the negative is going to pull an I out. That's the square root of negative 1. And that's going to leave me with a 44, right? Because if I do a little scratch work, negative 44, square root of negative 44 equals the square root of 44 times I. And then I want to recognize that 44 is the same as 4 times 11, so I can factor 44 into 11 times a perfect square. And if we have a perfect square, we can take the square root of that. So the square root of 4 is 2. And the square root of 11, which is a prime number, is already in simplified radical form. So I can actually pull this whole piece now, because I simplified it over here. I can pull it over here. This is going to be 2 times the square root of 11, and there's my I. And notice I have the midpoint of the fraction bar. I have the fraction bar in the midpoint of I. And then I want to reduce these fractions into lowest terms. So negative divided by negative is positive. 2 goes into both 6 and 8. So that will reduce to 6 divided by 2 is 3, and 8 divided by 2 is 4. We're really dividing by 2 over 2 right here. And then I get my plus or minus, and the 2 will go into the 8, and that's going to go in 4 times. This negative, I really probably want to pull the negative up into the numerator position, and I'm going to get a negative square root of 11 over 4 times I. And this is a little bit of a different situation. We have the negative sign here. Notice where you put the negative isn't going to matter in terms of making it a negative number. So if the negative sign is in the numerator, it's negative 1/2. If it's off to the side of the fraction bar, that's negative 1/2. And even if the negative is just down with the 2, this is negative 1/2. So usually you pull the negative up into the numerator position or off to the side instead of leaving it in the denominator. And what I want to notice is that this is kind of a special case because of the plus or minus. If I get a positive times a negative, I get a negative, and a negative times a negative is a positive. And then I wind up with the square root of 11 over 4 times I. So this is simplified completely. This is what t equals. And the key is that plus or minus and minus plus, it's really the same thing because we are going to get the same result. So this is a case where I could have just dropped the negative sign because of the plus or minus. But I think to really show that you understand what's going on, having the minus or plus, in other words, absorbing the minus and the plus into a minus and the minus and minus into a plus, kind of shows that you know what's going on. It's probably a good way to write it in this context.